What is up, everybody? Coming to you live from my garage. Once again, here we go. Little video on arithmetic series. Um, there's a story that goes with this that I just love so much. This guy by the name of Carl Frederick, I think was his middle name, and then Gauss, a very famous mathematician, contributed a lot. Um, into the sciences, electricity, astronomy. It's interesting. A lot of mathematicians were also astronomers. I think, there's with the space and math, there's just, you guys know, there's just a beautiful thing about the two of them. And I think people just wanted to feel like they had a piece of that beauty. But anyway, so the story goes this guy in fifth grade got in trouble with his teacher and they got sent to detention. So the person that was leading the detention put this problem up on the board, something like this, and wrote that all the way out to 100. And they said, when you guys are done with this, then you can take off. So probably about a minute passes, probably less than that. And Carl, fifth grade Carl, comes up to the teacher and says, all right, peace, I'm out of here. And he's got the answer written on his paper and he takes off. Uh, but how did that happen? Basically, it's this. Carl recognized this pattern in here where you see if you add up the first and the last term, you get 101. If you add up these two guys, you also get 101. If you add up these two guys, you get 101. So fifth grade Carl said, oh, I literally just have 50 101s. And okay, so here's my answer, 5,050, which is beautiful because that is essentially what we are doing with arithmetic series. This is a series, right? The common difference would be 1 in this. So basically the formula is this, and here's what you guys need to know from that little story. The sum of any arithmetic series uses this little formula right here. So in that little story, 1 was the first term, 100 was the second term. So there's your 101, and then there was 100 terms. So 100 divided by 2. So that's where he got the 50 times 101. Okay. S sub n represents like the sum of any amount of n terms. Okay. So that'll make sense when we check out some examples here. I got 2 written down. Let's look at both of these kind of side by side. So there's my first one, there's my second one. Notice in my first one, the last term right here is like in a little expression with n in it. So this answer is still going to have n in my answer. And then this guy, it stops at an actual number. So this is going to equal some number like 2000 or whatever that might be. Okay, so let's roll through here. The first one, let me write that formula down again. Oh, shoot. N over 2, a sub 1 plus a sub n. Okay. I don't know what n is in this case. So n is going to stay n. I do know a sub 1 is -1. And then a sub n is this guy right here, the last term. So 4n minus 5. So I'm just going to clean this up a little bit. So we got 4n minus 6. I could distribute the 1/2 through there. Okay. And then I could even distribute the n if I wanted to. But so either of these two answers I think would be cool. You could check the back. Oh, sorry, you can't see that. You could check the back of the book to see kind of what they have for that. Okay, and then here's the last one. Find the sum of this. So let's start with this guy again. Let's see. A sub 1 is 5. A sub n, that's my last term right here. So that's 49. And then I don't know what n is equal to. Okay, so check out how I get that. Last week, you guys looked at sequences. And remember, for an arithmetic sequence, we were given this little formula, right? You guys remember that? So a sub n, that's my last term, 49. A sub 1 is 5. I don't know what n is. And then the d value, that's the difference between each of these terms. And notice it's going up by 4 every time. So let's see if we could do this here. I'm going to distribute that 4. Let's see, so 4n plus 1, subtract 1. So n is equal to 12. I'm going to take that guy, plug it back in to over here, and right here. So s sub 12 is 12 over 2. And then 49 plus 5, what is that? 54. Oh, let's see. This is going to be 12 times 27, and then whatever that is equal to. So the sum of the first 12 terms is going to be equal to it's like 324 or something. Hang on, I got my calculator right here. Oh, yeah, 324. So there you go. All right. Goodbye, everybody. Enjoy. Hope this helps.